Building an expression tree. So here's the postfix expression. The first step is to create an input queue of nodes storing the values of that expression in the order in which they appear in the expression. I will have a stack called a node stack. I call it node stack because each of these nodes are going to spend time in the stack en route to becoming a part of the tree. And then I'm going to have a little rectangular canvas that I'm simply going to use as a place to draw my binary tree on. So, first node, 6, it's a number, so I push it onto the node stack. Then, whenever I push a number onto the node stack, on my canvas, I'm going to create a new independent node storing that number. So, the next number, 4, pushed onto the stack. Then on my canvas, I create a new node storing the number 4. Next, I have 3, push it onto the stack. Then on my canvas, create a new independent node storing 3. Next, we have 2, push it onto the stack. Then on my canvas, create a new independent node storing the number 2. Next, we have multiplication, a binary operator. So before we push the operator, I'm going to pop two values, 3 and 2. Then I'm going to push multiplication. Then on my canvas, 3 and 2, the two numbers I just popped, become children of that operator. Next, we have plus, a binary operator. So I'm going to pop the top two values, 4 and multiplication. Then push the plus. Then on my canvas, 4 and multiplication become children of the plus sign. Next, we got multiplication, binary operator. So we're going to pop the top two nodes, plus and 6, push multiplication. Then on my canvas, plus and 6 become children of the multiplication operator. Next, we got 5. Push it onto the node stack. 5 is a number, so we're just going to create a new independent node storing that number. Next, we have minus, a binary operator. So I'm going to pop the top two values, 5 and multiplication, push minus. Then on my canvas, multiplication and 5 become children of the minus sign. So, I have my tree. Now that I have my expression tree, it's now easy for me to write my expression in postfix, prefix, or infix form. To get the postfix expression, all I need to do is a post-order traversal of the tree, where I go from the left child to the right child to the root. And that completes the post-order traversal. To get the prefix expression, I'm going to do a pre-order traversal, which visits the root, then the left child, then the right child. And that would be my prefix expression. Then to get my infix expression, I'm going to do an in-order traversal with one extra step. What separates an infix expression from a postfix and a prefix is that an infix expression can have parentheses. So when we do the in-order traversal, every time we encounter a binary operator, we're going to insert an open parentheses into the expression because a binary operator indicates that we are beginning a new expression. So we start at minus. Minus is a binary operator, so I insert open parentheses. Then I go left. Multiplication, a binary operator, so I insert parentheses. Now I'm at 6. 6 is the first node that would be visited in an in-order traversal, so 6 gets inserted. We come back up. Now we're at the root of that subtree, so multiplication gets inserted. Next we go to plus. Plus is a new binary operator, so we're going to insert new open parentheses. Go down to 4. 4 is a leaf. It gets visited. Come back up to plus. Plus is the root of that subtree, so plus gets visited. Now we're at multiplication. Multiplication is a new operator, so we're going to insert another set of open parentheses. I go left to 3. 3 is a leaf, so 3 gets visited. I come back up to multiplication. Multiplication is the root, so multiplication gets visited. I come down to 2. 2 is a leaf. 2 gets visited. Now I'm back at multiplication. I look at the operator. I see that both the left and the right subtrees have been processed. Thus, that means we've completed that single expression. So we insert close parentheses. I come back up. The same can be said for plus. Both the left and right subtrees have all been visited. So we insert another set of closed parentheses. I come back up and I say the same thing for multiplication. Both the left and right subtrees are complete, so we draw another set of closed parentheses. I come back up to minus. We're back at the root, so I visit that minus. I come down to 5. 5 is a leaf. We insert it. Come back up to the root. Both the left and right subtrees are complete, so now we can insert another closed parentheses. That's completing our traversal. Now, this answer is correct as is. If you were to leave it like this, there'd be absolutely nothing wrong with that. However, you probably noticed we do have more parentheses than we need. So if we were to trim the extra parentheses, our final answer would look like this. But that being said, this answer is no more correct than the one prior to it. So in summary, when creating your expression tree, if the node you encounter is a number, push the node onto the node stack, then create a new node on the binary tree that has no parents or no children, just an independent node containing that number. Then if the node you encounter is a binary operator, then pop the top 2 nodes off of the node stack, push that binary operator onto the node stack, then in the binary tree, the 2 nodes that were popped, make them children of that binary operator that you just pushed on. Once your expression tree is created, use a post-order traversal to obtain the postfix expression. Use a pre-order traversal to obtain the prefix expression. And use an in-order traversal to obtain the infix expression with a couple extra steps. Whenever you meet a binary operator, insert an open parentheses into the expression. And then once both the left and right subtrees of a binary operator have been visited, insert a closed parentheses into that expression.